Hey guys, in this video we're going to look at solving logarithmic equations where every single term in the equation is a logarithm, okay? There's a certain way that we can do this, and we will be using this theorem right here that says if you've got two logs with the same base that are set equal to each other, then their arguments, the x and the y terms right there, have to be equal. Okay, this is similar to how we do one of the types of exponential equations that we've looked at already. The difference is this is a lot easier to work because you don't have to worry about getting common bases. They'll already be the same. Okay? All right, so let's take a look at the steps. The first step is to condense your logarithms so that there is only one on each side. Okay, so if you have several logarithms, then you need to be sure that you've got it condensed down to one on each side. You do need one on each side though, so don't condense to one in the whole equation, okay? Put one on either side of the equal sign. You can move your log terms around if you need to while you're doing that. Then what you're going to do is apply the property that I just showed you, and you're going to set the arguments of those two logarithms equal to each other. And from there, you will be able to solve the equation. You're going to solve the equation for x in this particular case. And then the last step, on any logarithmic equation, you have to check the solutions. Whoops, sorry. We want to check the solutions, and what we're checking for here is that the arguments must be positive numbers. So when you plug the solutions back in, you have to get positive numbers in the arguments. You don't have to do a full check, but you do have to check for that. Okay, we don't want negative numbers or zero in the argument. All right, let's take a look at an example. Get this page down. This is a fairly big example here. I did one that would kind of show you sort of what you could run into. We've got three different logarithms. I've got a logarithm here, and then I've got two over here on the other side. So what we need to do is to condense down so that I just have one on each side. You can either leave this alone as I did and condense them here. Okay, we've got sum of two logarithms. Both logarithms are positive, so that will give us a product of the arguments when we put them together. Remember, condensing is from section 4.4, okay? So I put these two together like this. I get a product of the two arguments, and then I multiply that out. You can either do it as you write this set, this step down, or you can do it as you are setting the two arguments equal. I've got natural log on both sides, so the bases are the same. So if this is to be true here, this equation, then this argument and this argument have to be equal to each other. Okay, so this is the multiplied out version of this. Scoot up a little bit more so y'all can see what I'm doing here. It is quadratic. Okay, you'll notice that, whoops, right here. Okay, so what we have to do for a quadratic is get everything on one side. So move the 3x over and combine it with this one. Move the 8 over and combine it with that. So I'll subtract 3x and get 5x. I'll subtract the 8 and get negative 12. So we've got 2x squared minus 5x minus 12. That will factor, okay, into these two. Now, if you don't want to factor it, you can use the quadratic formula. That's fine. But we get those two factors, which then give us, when we set each factor equal to 0 and solve, we get a, and I'm sorry this is already marked through, but we get a, not much of a surprise here, is it? We get a negative 3/2 right here and a 4 right here, okay? I'm using the notes that I did in class the other day if you're wondering why all this is already worked out to save us a little bit of time on getting the videos done. So what happens is we have to check both of those, okay? So I go back up and I grab my original problem, which was this nice long logarithmic equation here, and we check each solution in every single argument. If it makes one of the arguments negative, it won't work, so I can mark it out at that point. So plug it in the negative 3/2 that we got first. Right here will give me a negative 9/2 plus 8. That's a positive 3.5, so we're okay there. But then plugging it in here, negative 3/2 times 2 is going to give you a negative 3. Plus 2 is a negative 1. That won't work, okay? This cannot be a negative number, and so that's why I went ahead and crossed out the negative 3/2 problem. Next, we check this one, the 4. and I've just got that drawn down below here, okay? What we see is 4 times 3, or 4 times 3 is 12. 12 plus 8 is 20. 4 times 2 is 8. 8 plus 2 is 10. Still positive, we're okay. And then 4 minus 2 gives me 2. So all 3 arguments are positive with the 4 plugged in. That means that we get to keep the 4. Okay? And so that's my answer there. All right. So that gives you an idea of what to do if you've got more than one logarithm. Now for the other method, for solving logarithmics in my other video, you'll just have one single logarithm, so you won't have to worry about condensing there, and you can take a look at what that looks like.